Hello again, Harry here. To kick it off, we have to jump into what are the rules of TDD. So there are three main rules of TDD. Number one, you shall not write production code other than to pass a failing test. What does that mean? Tests come first. Number two, you shall not write more of the production code than necessary to pass that failing test. So it may be tempting to start adding extra stuff while you're there, but it might not be needed to pass the failing test that you're busy fixing. Cool, and you shall not write more of the test than to make it fail for the right reason. This means don't overcomplicate your test. Keep them simple, keep them testing one thing at a time. Don't try and test 10 different things in a single test. This is a common mistake that people make when they're not doing unit tests properly. And a good principle to follow is called triangulation. Only implement the logic once you see the pattern repeating 3 times. So we'll try and see some examples of that. The alternative to TDD is obviously TLD, which means test later development. And unfortunately, this is the bucket most people fall into. People don't build and use TDD properly. In most cases, developers just try and punch out a bunch of code, and what happens is it delivers eventually quite unstable software. It's going to cause your organization trouble when it comes to having stable releases, having quality assurance, and having really heavy regression testing whenever you're just trying to release the most small little feature. This can really hinder your products and your organization's growth in the long run. So let's learn TDD and let's try and do it together. Just a note, you can all pop over to the .NET.currency converter GitHub repository under my GitHub username Harry Hawthorne, and what you will find is the full implementation of the project, and each of the videos goes through little bits and pieces of this. For example, the first part of this video, we're going to be looking at unit tests in the domain folder, and so you can head on over here and have a look at all the unit tests that were written at your time. Pause in the video. I'll try and link the GitHub sections to the relevant parts. You can go ahead and look at what the unit tests look like. You can go ahead and also look at the implementations of the code, and yeah, hopefully this will allow you to pause as you go along if you feel that you needed more time to look at it. I'm sorry, I do realize I've shot through it extremely quickly. Always open to your feedback on everything and anything. I'd like to just make this learning series as easy and fun as possible. So yeah, in this video we're going to cover the domain layer, which is the most important part of our domain driven design. I'm just showing you an example. Domain driven design is a way to design your architecture where you create aggregates around important parts of your domain, such as an order, which is fully self-contained, a payment, a shipment, a product, a category, or a customer. The order here is called the aggregate root. All of its children, such as line item, are contained within order, and they never reference outside the scope of an order, and all transactions of an order take place with the full order. Same with the shipment. And these here are called value objects, an address and a price. This was the address of the shipment and the price of the shipment. In a nutshell, a value object is something which doesn't have an ID. It's just a thing, like an address or a price. Or in the example, we'll get into a currency. You can also see an important thing about domain-driven design is that nothing from outside aggregates are directly linked through navigation properties on an aggregate. It's fully self-contained. So product has a category ID, and category is fully defined within its own aggregate. You will never be able to access a category directly through a product, so it keeps its integrity. Okay, cool. So to start off with, I'm going to go ahead and create a domain folder, create a results folder. I mentioned we're going to be building the result pattern, so let's start with this. I'm going to create a success should, and then we start off by saying a fact, and we can say set success true. So that's what it should do when you call success. So no class exists for this, so I just need to create a new class, and I will create a new folder called shared. So there's no method called success, so let's go ahead and create the method, and let's go ahead and say here is success should be true. Inside results, we can just make this property bool is success, and we're not going to do anything. Okay, we're doing TDD, so yeah, jumping back here, we should be able to do should, but I need to add fluent assertion, so let's go and do that. And let's run my test, And now that we have a failing test, once it runs, we can go ahead and implement something to make a failing test pass. Hey guys, so at this part of the video I have sped it up at 800% and divided the full length into 4 little sections. So this was the whole process of me building out the result, and it takes a little bit of time to do TDD, but it's important, like I'll discuss at the end of this little section. And again, just to repeat myself again and again, the rules are: you don't write more production code than you need to make a failing pass, and you don't write more code than that's needed to make the failing pass. And you don't make your test do more than it needs to. It just needs to fail for the right reason. So like in the example, success should set is success to true. I didn't need to go and write out the logic. All I had to do was in that method hardcode is success true. And the next test I wrote was failure should set is success false. Now suddenly the previous test started failing, so I had to implement some of the logic which checks that it should set false. And so this is how you slowly build up, by writing your tests first and then building up and building up. And by the end of this little section, you'll see like I've written out all the tests needed for this result, which is super crucial for the entire system. But yeah, we're going to be building out the entire solution with TDD. So by the end of this video, we'd have sped through the entire domain using these principles. So we've created the result. So with that, let's have a look at my test results. We can already see, like, just for the result, which is a few little success and failure things, we've got 20 unit tests. So it just goes to show when we're starting from like one little nut in the application, which is going to literally be used everywhere. Like this result pattern is going to be on every single method. So it should be important that it works correctly, right? Just goes to show like it's going to save us a lot of trouble in the long run. So yeah, let's continue with the rest of tests for the domain model. So looking at our plans, what I'll do is I'll start by creating the currency code test. So we'll do the from code should, and then we will go ahead and do our currency snapshot. So we're going to test first probably the create should and then the convert should. So let's jump into that and see what it looks like. Jumping into this next section, let's take it down a gear. We're going to try and see an example of triangulation. We're going to just see what it's like to set this up from the start more slowly. To start with, create what we call the currency codes. And so I like to name my folders after what the class is that I'm testing. And then inside here, I'm going to name the file after the method that I'm testing. So from code should. And then we can group everything that from code method should do inside here. To start off with, we can create the fact, and let's say public void return ZAR. Now let's go ahead and create this. So result equals currency codes code dot from code, and let's put ZAR in, and we should say that result.value should be ZAR. Now of course none of this stuff exists yet. We can go ahead and create it. Click control dot, and you're going to say generate class in a new file. Going to make this one public because we're going to move it. I'm going to say control X to cut it and control V to paste it. And I'm going to create my first folder here, which is going to be called currencies. And let's update the namespace. Namespace gets added. And now, of course, we don't have the method, so we just have to say control dot generate method. Easy as that. It's going to give us an object, which we don't want, but it does realize that this should be static. But we want it to return a currency code. And our test is demanding something called value. So, okay, thank you. GitHub Copilot, you're smart enough to realize that that's what I'm doing. So let's create a protected. Oh, there you go. And now we can create a new one like this. Return value. See if I can remember how to code. And have I written a working test or a broken test? See, I feel like I implemented more than I was supposed to, right? I broke the first rule. I wrote production code without having a failing test first. So, but that gives you an example. So I was supposed to just leave it as not implemented and then have the failing test and then write the production code, but that's fine. This will now support like anything, this implementation. So we can turn this into a theory and we can start putting something called inline data. Here I'm going to say return correctly, and I can write it like this. And now what I can do is I can go and add in all the different currency codes that I want to support. And now this is fine, and so it should return correctly. So, and we've got these tests all returning now. But what if I put in a code that I don't want to support, right? So let's try run the tests. Okay, so now that this test is failing and we need to make it pass, we're going to have to look at how we're writing this, because if I were to put hard-coded things in here, that's not what I want. I want to only support my supported ones, and I don't want to break that test. So the way I'm going to do it is I'm going to create something like this. I'm going to create private members, and let's go and copy the allowed ones, and these are going to be private static read-only currency code. So again, like you'll see that all my valid ones are still passing, but of course we haven't yet implemented what we want for the unsupported, and we said that it needs to give an error of the code is unsupported. So let's copy that. Okay, there it is. Cool. So that shows you how we're going to approach building this solution out. And yeah, let's jump into the next pieces. Hey guys, I have jumped through and completed the domain. You can see that in the end I've got 100 tests just for this simple little few value objects that are inside my domain, and we have got the working and running unit tests. For the purposes of this video, I couldn't go through and show you like typing out every single unit test, but I have gone and completed this, and I did TDD for every single functionality I need for my domain like we planned it, starting from the from currency code, which you saw me do, and jumping into like the currency snapshot. These are the different things we talked about. It should have a code, it should have a date capture and an exchange rate. We should be able to create it and we should be able to convert it. And I also added that I should be able to find that it's a legal conversion, because I made an extra little use case for illegal currencies that we should not be able to convert to. If you look at like the convert should, we handle all these because you can put in a number and it should be able to do the conversion correctly and give me the amount. It should fail with an illegal character and it should fail when not found. If you read the method, these are the different things. So you can see each of these clauses have test coverage, and then the same thing with the create. We've got tests for every single thing you can do, and same for the is legal conversion. We check with this inline, like these are the illegal ones and these are the allowed ones. Looking at the result, I didn't show you the full like scope of this. These are the different things that we need to be able to do with the result. We need to be able to return a result. It needs to be able to use this implicit operator. So we wrote tests to give coverage for all this functionality, and that includes like the cases for failure, the cases for failure with generic type, the cases for success, and the cases for success with generic type, and the way we need to use the implicit operator for returning results of anything for our applications. That wraps it up for the domain part that's been unit tested. I look forward to jumping into the rest of the other parts like our application layer and infrastructure. And give this video a like and a subscribe if it was useful to you. I hope this content is awesome, and we're going to jump into more awesome stuff we can do with .NET. So stay tuned for the next video.